This is Travis Anderson and Ryan Duda, and we're going to be talking about heat transfer through windows for our personal project. Many new homes are attempting to be more energy efficient, and some home designers are striving to say that they have a net zero home, meaning the total amount of energy used by the building on an annual basis is roughly equal to the amount of energy produced or captured. One large impact of heating and cooling costs in a home is the window type and size. There are many factors to consider in a window for it to be energy efficient. Our project involves researching different types of windows that are offered and its influence on heat loss or gain in a home during the different times of year. Variables that influence heat transfer are the window size, the number of windows, window shading, the solar heat gain coefficient or SHGC, and the U factor. Changing any one of these variables can have a large impact on the heat that is transferred through the window. These variables affect both heat entering the home as well as the heat leaving the home. In cold weather, the insulation of a window has a direct impact on how your home feels. Windows not only affect how you feel, but also the amount of money spent on either heating or cooling your home. As taught in heat transfer, we can use an energy balance. There are three things that can happen when solar energy from the sun strikes a window. The energy will either pass through the glass, be reflected by the glass, or absorbed within the glass. The solar heat gain coefficient is the fraction of the solar radiation released as heat inside a home through a window. The SHGC rating ranges from about 0 to 1. The lower the SHGC value, the less solar heat the window transmits. Different SHGC values are recommended based on the climate the house is in and the direction the window is facing. For example, the SHGC rating of windows on the north side of the house may not be as critical as the windows on the south side of the house because they will not be in direct sunlight. Heat leaving a house also needs to be accounted for. The rate a window conducts non-solar heat is expressed as a U factor. The U factor is the overall rating of a window's resistance to heat transfer. Much like insulation in walls is expressed as an R value, windows use a U factor. This method is used to calculate the overall resistance by taking into account the number of panes, the type of glass or coating on the panes, the spacers in the window, and the gas used between the panes. The picture on the right shows an example of using a resistance method to calculate heat loss through a single pane window. We have designed a spreadsheet that allows the user to select from the most popular design types of windows, and by inputting the size of windows, the spreadsheet can give the user an estimated amount of heat loss or gain through their windows. The outputs are calculated using average values for the amount of solar energy for each month in Rexburg on a south-facing window. This is our Excel spreadsheet. The first thing you want to do is come down to window type. The top row is for clear glass or just a normal window without any special glass or reflective glass or anything like that. The second box is for your newer windows or if you were to replace your windows. So we're going to do a single hung window type, which if you don't know what that is or don't know what your window is, you can look up to the top here and it has some examples of what each type of window is. But here in Rexburg we use a lot of single hung windows, so we're going to go to single hung. And the thickness of the window, you can change it to multiple different thicknesses, but we're going to stay with 3/16. So the glass for the top one is going to stay clear because that's the common norm for a lot of the windows around here in Rexburg. And within here you can choose by different types. You can do a low E2 or a low E3 or a low E2, and there's also some graphs up here or some figures that will help you to be able to understand what each one of those are. So we're just going to do a low emissive 2 glass window. Panes, we'll just do a dual pane. You can choose between a triple and a dual pane. Some of the triple panes don't show up because they don't make any. Spacer, we're just going to do a foam spacer, and then there's ability to go to air or argon. We're just going to do air for different, so it's a little bit cheaper for us. So with this, all these parameters put in, it gives us a U factor, an SHGC factor, and a visible transmission light factor, you could say. Some other inputs is what size is your window, a width and a height, and then how many windows are on this wall, or how many windows do you want to calculate for that wall, what your comfortable inside temperature is, and then how much does it cost you in your house for electricity. So after you put in all these numbers here, you'll be able to see that the cost of heat loss through your new windows is only $13.63 compared to $18.06 for your old house. Now these are based on a per year basis. So per year, if you upgrade your windows for only having 3 windows of that size, is $4.44 per year. If we go and change some of our parameters to maybe let's have 6 windows, it's going to jump up to be about double. Or if, let's say that we want to change it to a different type of a window, maybe a different type of glass, we can see that the values change, and also the cost of our new windows to old windows changed. So you could be able to mess around with this and be able to determine which type of window and which type of glass best matches Rexburg, Idaho.